Hi everyone, right? Welcome back. This one is going to be part two, right? Video, right, for the solving of inequality, right, for H2 mathematics, right? So during the first part, okay, we actually have gone through, right, the way to actually solve quadratic inequality, right? So quadratic inequality, right, is something that I've learned before, right? So we actually have commented that one of the best ways is actually to solve using a graphical approach, right? Because quadratic equation or quadratic graphs rather are pretty easy to sketch, right? Once you actually know the basic details, right? So for this second part of the video, right, we're going to actually advance a bit, right? We're going to do something slightly tougher, right? We're going to actually try to solve for higher order polynomial quadratic. So as you can see, we're no longer sticking to quadratic, which is power 2 already, right? We need to actually learn how to solve for cubic or even a quadratic, meaning a power 4, all right, polynomial quadratic, polynomial inequality, right? So let's get started. Um, Now, for solving of cubic, right, let's start off with this question 2a first. Okay, so for solving of cubic inequality, there are a couple of ways. Okay, so definitely your school will teach you, I believe, at least two ways. Okay, so for today, okay, I'm just going to stick to one method which I find that okay is very easy to use. Right, so for this one over here, right, we have a cubic polynomial. Now one possible way, okay, of course, okay, to solve for it, okay, is actually the graphical approach. Okay, just like how, right, we have solved our quadratic inequality in the first part of the video. So we can actually use a graphical approach. Okay, but of course, right, some of us will ask, oh, how do I actually even draw, okay, a cubic, okay, graph? There are two ways. You can either use a graphing calculator, right? A graphing calculator, right? That we will get it very soon. Okay, or right, you can actually just use some analytical okay, method to actually sketch the cubic graph, which I'm not going to cover for today, right? So I'm going to basically just say that hey, let's just use a graphing calculator approach, right? So graphing calculator, right? I'm not going to run through it here. You press it and you will realize okay that the graphing calculator, right, will actually ask you to, or rather will tell you that the shape of the graph okay, is going to be looking something like this, right? So again, you notice that I didn't draw the y-axis because the y-axis is not extremely important again when you're solving for inequality. Alright, so as usual, right, we are expecting to see that the graph will actually cut the x-axis at 3 points again because if you were to look at the original expression, right, there are actually 3 factors, right? So we just need to equate each of the factor, right, to 0 to solve for the usual roots. So the smallest root is going to be -4, followed by half, and followed by 3, right? So as usual, right, you're going to basically shape the part of the graph, okay, whereby it is actually lesser than 0. Right, so lesser than 0 means there's two ways to look at it. You either actually say that it's the part of the graph that's below the x-axis, or you can actually tell yourself that I'm going to find out the part in which the y values or the y coordinates of the graph are actually negative, right? So it's going to be over here and over here at this part. Right, so therefore, solution, right, as you can see, there are usually two regions over here. So x is going to be between -4, half, or don't put a comma, I repeat, okay, you must not put a comma because it's not an acceptable mathematical symbol, apparently. Right, so or, right, you're supposed to say that x is actually greater than 3. Right, so done already. So over here, this one is actually our first method, right, using a graphical approach, which of course we need to learn how to use our graphing calculator to sketch. Okay, but of course, right, most often than not, okay, using a graphing calculator, even though it sounds pretty easy, okay, at times okay, it's actually quite cumbersome, okay, because the GC, right, the graphing calculator, might not actually sketch the graph right nicely for you, and it could actually be quite time consuming as well. So that's the reason why we at times, right, we will actually want to use a second method okay, of solving, right, which as the title over here suggests, okay, we're actually going to use the sign testing method. Now, different school calls this method differently, right? So during my time, right, we actually tell students that, oh, we call it the sign testing method. Now, how does it work? Okay, it is actually very, very similar, right, to the graphical approach, except that we don't actually sketch the graph out, right? We simply just say that, oh, okay, right, as usual, right, we're going to start off by drawing the x-axis, and because the expression is already factorized for us already, right, we can actually still do the same thing. Okay, mark out the roots, right, as usual, right, and these roots, right, okay, will actually divide the x-axis, okay, into a total of 4 regions: 1, 2, 3, and 4. Okay, now what do we have 4 regions? Well, for those of you who are fast, we can actually just relate to the graphical approach, right? But anyway, okay, I'll explain a bit more. Now, as I mentioned, the 3 roots will actually divide, okay, the x-axis, right, into 4 quadrants. And over here, how do we actually continue with the sign testing method? Okay, is this. Now, as the name suggests, right, I'm actually going to test each of the region, right, for the sign. Okay, so how do we exactly do it? Well, for example, right, I'm going to actually do a quick, I'm going to do a try and error to say that, okay, on the number line or on the x-axis, I am going to choose, right, a value of x that is not a root, right? So for example, 0. So we choose the simplest value, right? So using this x value or this x coordinate is 0, I'm going to actually sub this x equals 0 right into the expression, okay, or if you want to, the equation of the graph. So when x equals 0, right, I will have 0 plus 4, right, 0 minus 1, and 3 minus 0. So I multiply them together. I notice that, oh, it's going to be a positive value multiplied to a negative value multiplied to a positive value, right, from each of the factor. And I will actually get an overall sign of a negative. Right. So as you can see over here, right, when we're actually doing the sign testing method, we are not actually interested in the actual, in the final value, right? We're only interested in the sign, right? The overall sign, okay, for this region. That's why we call it the sign testing method. So I'll say that, oh, over here in this region number 2, it's going to be a negative region. So of course, what it means, okay, in plain English, okay, is that regardless of what x value that you choose between -4 and and positive half, the y coordinates will always give you a negative, right, a value, which of course, as I said, compare with the graphical approach, right, which is pretty, right, obvious already, right? So of course over here, right, this actually what this actually has the same meaning. So you do the same thing, right? You do the same thing again for the rest of the region, right? So you can actually choose a value over here between half and 3, right? And of course, a value, okay, greater than 3 and a value that's actually lesser than -4, right? You run through the process again, right? You will actually get, okay, to see that, oh, for example, in region 3, right, you get a positive region, right? Which means regardless of what x values that you choose between half and 3, the y coordinates is always going to be positive, right? And of course, for region 4 is a negative region, and region number 1 is going to be a positive region. So of course, it must correspond, okay, it must agree with the graphical approach. All right, so from here, I'll therefore conclude, okay, that the solution for this, right, is going to be taking the, right, negative region part, region 2, region 4, right, because remember we are solving for less than 0. So therefore, right, x is of course between, okay, the two, oops, sorry, right, the two sets of answer, okay, that we have already solved just now. Okay, so otherwise, okay, I'm done already for this question, right? We're good to move on, okay, to question number 2b, right? Similar question. Remember, you can always pause, right, before you actually pause to actually allow yourself to do the question first, right? And anytime you're stuck, right, just unpause the video and hopefully, okay, the way that I actually going to run through the question, okay, is going to help you at the stage you get stuck at. Okay, so otherwise, okay, let's take a look at question number 2b. Right, so we're supposed to solve for this quartic inequality, so power 4. Okay, so quick glimpse again and make a comparison between 2a and 2b. You realize, oh, 2b, right, we need to actually do something extra. Okay, we need to first of all factorize, okay, the entire expression first, because if you do not actually factorize it, right, just like question number 2a, right, it's going to be difficult to actually list out the roots, right, on the x-axis already. Okay, so of course, before we start, okay, I'm just going to comment again on one quick careless mistake that you might have already made. Right, so for this one over here, right, first step, right, the first thing that I need to know, tell you, okay, is this, right, you must never ever divide throughout, okay, by an x square. Okay, no, I know it is very convenient, okay, it seems very convenient, oh, just divide by x square away. It's not that you can't, right, technically you can, okay, but most students, you do not know when they can and when they can't, right? So I'm going to say that over here, don't divide by x square away, because you will be missing some solution along the way, right? So just do the right proper way out, right, which is actually to say that, okay, lor, right, since I can't divide throughout by a square, right, I'm going to bring everything over to one side, right, bring everything over one side, okay, and then after that, make sure that the right hand side is always 0, right? So ensure that the right hand side is always 0. Right? Why 0 then? Because it'll be easier to actually solve, right, subsequently. So once this is done, right, as usual, right, we're going to do a factorization, right? So it's pretty easy. So take out the x square, f x squared minus 2 minus 3, oops, x, right, over here, greater than or equal to 0. Right. Now, as usual, remember to always use your calculator, right? Use a calculator, right, to check, right? To check what? To check on the nature of the roots, right? To see whether are you dealing with exact roots or very nice roots, right? Or roots that are decimal points, which means you will not be able to factorize that easily, right? Or the third type, okay, check whether um, your calculator give you imaginary roots or not, right? So if it's imaginary roots, okay, it's going to be a totally different type of question, really. Okay, but otherwise, okay, for this one over here, right, I believe it is factorizable, right? In fact, we do get some very nice factors. X, let me see, minus 3 and x plus 1. Okay, greater than or equal to 0. Okay, then from here, right, as you can see, right, once the expression is fully factorized already, right, we realize that, oh, right, very nicely, we actually have go back, right, to question number 2a type of question, okay, whereby everything, right, is factorized already. Okay, so alright, so as you can see, right, go back to question 2a type where everything is factorized already. So as long as everything is factorized, okay, we can actually now write down, okay, the roots properly, and we are actually going to again, right, practice our sign testing method, right? So I'm not going to use the graphical approach. Alright, so sign test method, right? I'm going to run through the whole thing again. Alright, so if I should try it, right, just see whether it is the same thing or not. Okay, so remember, we do not need to draw the y-axis, only the x-axis. Alright, so the first thing is, again, I'm going to, right, mark out all the roots, right, on my x-axis. Right, so I have the smallest being -1, right, followed by 0, followed by 3. Right, so there's going to be a repeated root at 0, right, for obvious reason, because it's actually an x square expression. Alright, so the 3 roots, right, once you mark out, is going to, for this question, divide, right, the x-axis, right, into a total of 4 different regions, which means the graph is going to have 4 different behavior in some sense, right, at each of the region. So once it's done, right, remember, as the name suggests, we are going to actually test the sign, right? So when you actually test the sign, you're supposed to choose an x value, right? But you're never ever supposed to choose the root itself, right? It's going to be quite silly, right? Because if you choose the root, it's just going to become 0. So I'm going to choose a value that is quite simple to use. For example, x equal to 10, for example. Okay, not too big, right? Alright, so from here, x equal to 10, what you need to do is, with this x value equal to 10, you're going to sub it into, okay, circle the wrong thing. Right, you're going to sub it into, okay, this expression over here, this factorized expression, right? So when x equal to 10, okay, I have, right, 10 squared, right, so I have 10 squared. Then I have 10 minus 3, which is 7. And after that, I have actually 10 plus 1, which is actually 11. But I'm just going to tell myself okay, that, hey, we are not interested in the actual value. I'm just interested in the sign. So it's going to be positive multiplied to a positive number, multiplied to a positive number, which gives me the overall sign of a positive value. So which means for this region here, it's going to be a positive region, which means that if I were to draw the actual graph, right, I would expect to see that the y coordinates, right, in this region to be always positive, which means the graph is always going to be above the x-axis. Right, then from here, right, you just need to actually do it very quickly, right? So let's try out, for example, this region over here, right, between 0 and 3. So I'm just going to choose x equal to 1, right? So when x equal to 1, okay, I repeat the procedure, I sub it inside the right expression over here, right? So I will have positive value, right, multiplied to a negative value, multiplied to a positive value, right, which is going to be negative. So as you can see, okay, I am no longer interested in the actual value already, only the sign. So negative, right? So we keep on repeating, right? For this one over here, I believe it's going to be negative. This one over here is going to be positive, right? So that's how it is done. Okay, of course, right, what is also nice is that once you actually have the region, right, you can actually make a guess, okay, how the graph actually look like, right? So I will say that, oh, since I have a positive, negative, negative, positive region, the graph, if I were to use my GC to draw it out, probably be looking something like this. So going from top to bottom, so going the negative, right, cut the graph, right, and x equals 0. But as you can see, right, from 0 to 3 is actually a negative region, so the graph must go down again. After that, it goes up, and after that, becoming positive region. So it's something like a W-shaped graph, right, for this expression over here. Okay, but anyway, regardless, right, let's complete the question already. So we need to solve for greater than 0, right? So take a look at the final statement. Okay, we're solving for greater than equal to 0 over here. So which means, okay, I need to basically choose all the positive region, right? So therefore, x is going to be lesser than equal to -1, or x is actually greater than equal to 3. But here comes, okay, the tricky part already. Okay, now I can't remember which teacher actually or which college actually tested on this question. Okay, but I think it's quite a nice question. Okay, because it wants to trick students, okay, to end off their answers here, leh. Right? Why, leh? Okay, because this answer here, guys, okay, is not entirely correct. Okay, something else is missing. Right, something else is missing the solution. Right, where is it that's missing? Okay, so check, look very very carefully. Right, it's supposed to be a very tricky question. Right, what is missing? What is missing? I wish you can read your mind. I wish you can see your expression. It's like, huh, have meh? Of course, have. So over here, right, you need to actually also say that or x equal to 0, right? Why 0? Well, because if you were to look at the graph, right, or even the sign testing method itself, x equal to 0, right, is actually a repeated root, right? So repeated roots are always causing problem, right? So when x is equal to 0, if you were to actually sub it into the original inequality, you realize that 0 is indeed a solution, because 0 can be equal to 0 on both sides and stuff like that. Okay, so otherwise, okay, I'm done already for this one over here. Alright, so I hope you have actually enjoyed this video, right? And I'll be seeing you right in the next part 3, right? For much tougher question. Alright, see you.